Actually, I have. Did we talk about distance formula last time? We didn't. Did we talk about the slope formula? Oh, okay. We have to start with the basics. What is a point? What is a point? If I say, in order to graph something, what do you need? Yeah, a point is a location on a grid. A point has a horizontal, but that's not even true there. Because how did you first learn to graph in elementary school? What did y'all use? We just use a number line. Teachers say, where is the number 3? What would you do? You would put a dot right there. That is a point on a one-dimensional graph. But eventually with time, if you think about this, the graphing system progressed as humans progressed. How did we move? How did humans move at the beginning? They walked, rode horses, wagons, boats, bicycles, cars, and then came what? Airplanes, submarines. So then we had a vertical movement. So everything moves the same way. We have the number line here, and then the altitudes and depths. So how do you separate those two? Since alphabetically X comes first, this is also called an abscissa. This is called an ordinate, which is why this location is called a point. It's also called a coordinate. Co means with. It means here's this X value with this value. So what is that location? This is a location. So what is that location? This is the number 1. This is number yes. It's at the location 1, 2. And so far, what would that one be? Everybody should know how to do that. Remember how to do that, right? Here's the next question I have for you. What are these 4 quadrants called? How would you label them? And why would you label them that way? If we were to label them today, what would this quadrant be called? No. If we were to label them today, we'd start off with 1 here. Because then we would go clockwise, wouldn't we? But think of this. This one is 1. This one is 2. That's nowhere near how we would name it today. We would never go counterclockwise. Why did they do it that way? Yes. Okay, but what we say that one's positive, one's negative.
So you don't think they start with one because that's where it goes?
Nope. It was because it's the same reason we use, we would start off here because we would go clockwise. What clocks do they have back then? Not watches. Sundials. Where does the sun rise? Where does it set? It goes like this and like this. So that's the reason when they were looking at it, so well, because when they first graphed it, that's how everything was going. So that's where the naming convention comes in too. If you had 2 points, actually, if you only had 1 point, can you draw a line through it? You can, yeah, everybody would draw a different line. There's no number of lines. I mean, it's just any direction. Once you have a second point, now you have a specific direction. Now we have a line from point A to point B. So how would you define line? We use these words all the time, but do we know the definitions of straight? Would it be a line then? Or would it be a curve? Now, a line has to be straight. But there's a relationship between each point on this line. What is that relationship? They all have the same, they all refer to the same slope. What is a slope? Okay, yes, we'll start with there. Which I don't really like that because if it's rise, what direction is rise? What about, can you ever go down? You can never have a graph like this. So it's either rise or sink. It's rise, it goes up if it's positive, it goes down if it's negative. The bottom number is always running to the right. Why is that? When you have a fraction, the negative can either be in front or on top. Why is the negative never on the bottom? Yeah, why is the negative never written on the bottom? Ever, always. It's a common convention in mathematics that the negative number can never be on the bottom. I'll show you why. There are a bunch of negative numbers here. So what's the rule for adding and subtracting fractions? We have to have a common denominator. Do we have a common denominator? Yes. Then once you have a common denominator, the equation happens on top. -1, -4 is -5. Or if you want to, you can make the whole thing negative. But that's the reason why we never put negatives on top, because there is no operation. It says to make it so. What do you call the point that's halfway between there? What do you call the length between two endpoints? And what's going to be interesting is we're going to use the same formulas for lines and circles. That's pretty cool. I think it's cool. Let's see here. So let's first begin with a slope. For slope, what letter do we use? Capital or small? What does capital M mean? Why can that not be capital M? Because that is the midpoint. But what is the formula for slope? Why? Let's look at this. Is that the equation for a slope? Isn't that M right there? That's the equation of a line. This equation of a line in what form? Slope intercept, right? Which we'll get to that in a second. There's. But what is the equation? Remember, we talked about rise over run. Yeah, rise. This is the y-axis, and this is the x. So it's y over x. Yes, but going from one point to the next, what's the formula for a slope? It's the vertical change. It's more than like it is exactly that. Yes. So the vertical change. How do you determine change in equations? In other words, between the numbers 1 and 9, how many numbers are between there? Right? Okay, let's try something between 1 and 3. From 1 to 3 is 2 spaces. From 1 to 9 is. Now, is there an equation we can use using these numbers? 1 and 9 equals 8. 1 and 3 equals 2. Is there an equation we can use? It's a subtraction method because we're looking for difference between the two. The difference is how far are they apart, which is a difference. Difference uses what symbol? Subtraction. So if we took 9 minus 1, what does that equal? 3 minus 1 equals 2. So it happens for any numbers. If we started off at x1, how far is it to x2? Which would be what? Well, how would you find the distance between these two numbers? Well, same formula. This is x1, this is x2. What formula do we use? It would be x2 minus x1. The second minus the first. Same thing vertically. Understanding the why and the where, how did it come from? Where did it come from? That's more important than what is it? Because you'll eventually forget what it is. But in terms of where it comes from, it makes it more sense. So the slope equation is this. See, this equation starts all the equations of our lines too. Okay, so that's the slope. How do we figure out the midpoint? What exactly is a midpoint? First off, it's a point. You can find the midpoint of a line segment. So the midpoint would be somewhere halfway between there. Remember, it's a point. So what format does it have to have? Has to have an X and a Y. Very good. Remember, it's got to be halfway between there, right? That's what mid means. Mid means half. Halfway between the 2 points. So how do we figure out what number's halfway between these two? You could count it, but there's a faster way. Because what you have to do is start at 1 and 5, 2 and 4, and 3. So we know this number is midway between 1 and 5. Now, is there a math equation we can use to find it? We have 1 and 5. How do we get 3? Very good. If we took the two numbers, 1 plus 5 and divided by 2, basically mid means halfway. Halfway means average. It's the average of the two distances. So for the X component, we take the beginning X point and the last X point and divide by 2. Same thing vertically. Take the first Y and the last Y, add them together and divide by 2. So 1 plus 4 divided by 2. So it's 5 divided by 2 is 2.5. So it's there. So the midpoint of this line segment is 3, 5 over 2, or 2.5. Don't get the equations confused. The slope formula is x2 minus x1. It's the difference of the two distances. This one is the average. Average, if you had two grades, 100 and 500, your average is 300. So that's where you add and divide by 2. What are intercepts? That's what it is, but what exactly is it?
Where it crosses the line.
Right. Points where the graph crosses the X and Y axis. Those are intercepts. How do we find them? To find the x-intercept. So let's look at the graph of this function here. It crosses at negative x there and at positive, or whatever those values are. So this is the x-intercept, where it crosses the x-axis. The y-intercept is where it crosses the y-axis. So what are those locations? What's this location here? And this one here? So what's the location? Negative x0. Very good. And this one?
0. Oh, 0, 1.
You're just copying your answer. Right. So this tells us what we need to do to find the intercepts. To find the x-intercept, what do you have to do? set the Y value equal to 0. And then solve for X. Because when you do that, you'll come with some X value and the Y is 0, which is the X intercept. To find the Y intercept, set what equals 0? Set X equal to 0, right? And then solve for Y. So you'll end up with 0 value. What is the point of doing the intercept method? For both of them? No. Yeah, too far there. Eventually we're going to use zeros. We're going to use the term zeros. We're also going to use the term solution or solutions, which also means the x-intercepts. Solutions are the x-intercepts. Because solution is where we set y equal to 0. We'll also call these roots, factors. Those are all pretty much synonymous. We'll use them interchangeably throughout this course. Can you think of a real world application where you use intercepts? Right, and so if we have a rocket, it always goes in a parabolic arc. If we have the initial velocity, we know that gravity is negative 9.8 meters per second squared. We can figure out how far it's going to go up. We can figure out how far it's going to go out, when it's going to hit the ground. Yeah, we can do all that. Another example. Yeah. Yeah, for anything that goes up comes down. Actually, in sports, they use the same thing. In basketball, you have the shots that are done that way. Football, trajectories for the field goals. Ski jumpers, they have a modified trajectory. But linear equations are used more than quadratics. This point here is the starting budget. This is how much money we have on January 1st. If we're losing X number of dollars a month, what does this number tell us? Yes, because the x-axis is always time. So how long can we last if we keep on losing money? These are called forecasting, and that's what's really used. In some of the businesses, they use something like this. Well, this is your cost and revenue. What is revenue? How much money you make? Cost is how much it costs. So hopefully that the cost of the items have a slow rate, but you can keep on making money. Eventually, at this point, you'll break even. As long as your revenue is below your cost, you're losing money. As soon as it gets to this point, this is called a break-even point. At that point on, we'll make money. So the question is, can we survive that long before we start making money? And unfortunately, that's why a lot of businesses go unders, because they don't factor these kind of things in. We'll make money next month. We'll make money next month. Eventually, after 10 or 12 months, that next month they're gonna get there. So. How would you graph an equation? What are the different methods to graph an equation? Let's stick with linear so far.
You want to isolate the line.
Okay. If you do that, what form is it in? And what good is that going to do for you? How would you graph that? Well, let's go. Let's solve for y first. Let's do this one. Very good.
Divide everything by 2.
When you do that, do each term separately.
Wait,
Because if you went negative 3x plus 6 divided by 2, that doesn't tell us much.
you gotta divide each item.
Right. Not each what?
So,
Starts with a T, ends with erm.
um,
Yes. Plus, why do we must divide each term by 2? Because now each of these numbers tell us a different part of the story. What does this number tell us? That tells me the slope. What does this number tell me? The y-intercept. Why is that the y-intercept? In general, any equation, the constant number, if you solve for y, the constant is always the y-intercept. Why? How do you find the y-intercept? If you set x equals 0, all the x's are gone. The only thing left is the constant. So that's why the y-intercept is always the constant term. So to graph this, that's the only point you know for sure. To graph. Plot the y-intercept, the b term. So we have one, two. We know the y-intercept is 3. From that point, what do? From that point,
yeah.
follow the slope. The slope says go down 3 and over 2. Connect the dots. There's your graph. Is it always going to work? Let's see. Use that method on this equation. So what's my first step? Subtract 4x. because that's a negative. Change all the signs first. I treat my signs and numbers separately. Because if you don't, you'll have signs everywhere, lines here and there. You don't know if it's an equal sign or a negative sign. You'll get those mixed up a lot of times. So first off, change all the signs. Then this method won't work here. We know the slope, but we can't plot that. Negative 9/9 negative 1/4. It's not too accurate. So what other method would we use to graph this one? We can't use this method. What other method can we use? We know the slope. We can use that eventually. We need to find another point. We need to find a solid point somewhere. We can't use the intercepts. Yes.
Does it go like y minus, when the y equals y1 minus?
Oh, you're thinking y minus y1 equals m, one of those things? You could, but it's still gonna give us another problem. Because you still have to figure out, pick a value for x or y. What we would have to do here is we'd have to figure out some value for x or some value for y. When you plug it in there, it'll give us a solid number that we can work with. For example, 45. Because if we multiply everybody by 3, what's that going to give us? 12, 15, 27. That's not going to help us any. What we're looking for now is every graph, every line eventually has to cross at some point where it's a solid dot. You want to cross, you want a point that's at an intersection, not intermediary between 2 points, because that's not going to give us anything. So what we have to do is here is figure out what can we use here in this equation to find an x and y component that are solid numbers.
When you multiply it, let's multiply the entire.
Whatever you change one, you have to change them all. Because it has to stay equal. So if I multiply by 3 to this one, I gotta multiply by 3 to all of them. Or if I divide them all by 4, I get divided by all of them. Is there an easy answer to this one? Remember, all we know so far is the slope. We have to have a beginning point. We can't use the origin because 0, 0, 0 is not equal 9. We can't use the intercepts because negative 5/9 is not going to be a good point, or 9/4 won't be a good point. So how would we go about to finding a value that we can use? So next week, whoever brings me a solution to this will get 2 candy pieces. 1 Kit Kat, 1 Hershey.
One way I was thinking it was like, you can just, you can, it's almost like gambling, you just multiply everything until you find something that.
That's what you're gonna get to.
Yeah, like, wouldn't you wanna? Why, like I was thinking, like, 3 or 5 or something, by all those terms, so you can combine them as a variable and figure out the use of that one.
You could, but then what number do we multiply by? That's the key, is what do we have to multiply by? What do we have to do to each of these so that when we simplify them, it comes out with a solid answer?
But you don't want fraction.
Not when it comes to here, because when we find the y-intercept, we want a solid number. Because if you had a fraction, then if you had these lines here, if this was 1 and this was 0, this is -1, if it was, what value is that? Is that 1/4? Is it 5/8? Is it 9/16? So again, it's off by a little bit, you ruin the graph.
So let me do try to find multiples of 9 that are like a whole number.
Of 4, 5, and 9, yeah. That would give us whole numbers. It's not gonna be small, it could be large. But again, it's a bonus problem. You're trying to find me a point we can use to graph it. We just need 1 point. That's a solid number. No, I'm saying is that there's an X and Y value out there that when we plug it in there, it'll give us a solid answer. And what are those X and Y values? That's what we're looking at. No, it won't be the same. Because the coefficients are different. Bonus problem. It'll take you some time. Okay, so that's one way. Yes, we could, to graph equations, we could first off set them equal to y equals mx plus b. Graph them. What's another way? The intercepts. You can find the x-intercept and the y-intercept if they exist and they're not fractions or decimals. And then we could use those. What's another way of graphing equations? No. There's one more way. Yeah, use a calculator, yeah, but that'd be cheating. We use intercept method. We use the point slope or slope intercept. And what else? You all took algebra before. What do you need to have to find a graph? You need 2 points or what? Or 1 point and the slope. But if you think about it, both of these methods, that's what we just talked about. Here we have the slope. We have the slope, we just need another point. That's what we're looking for. Or earlier, we have 2 points. We have this one, and we use a slope to find the second point, and we graph them. It's another method. Use solving the equation, using intercepts. Think back your algebra days.
substitution? What is the question again?
Well, it's a third method of graphing equations. The substitution wouldn't work here, because that'd be the same as just plugging numbers in. Actually, I'll take that one. Yeah, okay, yeah. In other words, what do you mean by substitution? Choose an X value or a Y value. Plug it into the equation. And solve for the remaining variable. But there's an inherent problem with that one. It goes back to the question we just had earlier. If we plug in 3 in there, well, there'll only be a fraction.
It's still not gonna do.
It still won't do anything. All these are valid points y'all are making. Basically, I'm saying is, are all equations graphable? Well, they're graphable, but not without technology. Whereas if it's a linear equation, think of it, if a linear equation, it has to have some direction, some slope. Somewhere in the ether, it would get to a point where it's a solid number. It may not be in the simpler numbers. It may not be 1 through a million, maybe something like 12 billion, 400 something. It may be some number that's well out there that is just makes us think about it. But every equation is solvable. Every equation is graphable, especially linear, because it has a slope. We just need one point to begin. That's the problem, is finding that one point. Once you find that point, then we can follow the slope up 4/5 or whatever it was. You never want to use a fraction or a decimal as a point when you're graphing, because they're not accurate. The textbook, the software is going to allow you to use 0.5s, 1/2s, because the graphs will look at this, and the dot they give you is something huge like that. So it's not going to be precise, but say it's in this area. Yes.
Can't you just change the scale of your graph? Like instead of making your box 1, make your box 2.
You could.
Like, that'd be one way to solve the previous equation, right? But you have to have presumably a huge graph, to be able to work with. It's like-
Right. It's just, yeah, changing the domain of your graph itself. You could do that. But remember, if it's not in the first couple of segments, it may be out there further. But if you can do that, then you could algebraically, instead of changing the paper, change the equations accordingly. Right, you're absolutely correct, you can. But that'd be more work, because now I gotta take this graph, cut them into fifths or ninths. It makes sense, but again, we could run into some problems there. But yeah, you could try that. What I'm saying is, do not get discouraged if the answer doesn't come out really quick. I don't think what I've seen so far in the textbook, the questions they have in there are not yet, not mind-altering difficult. So they're going to give you stuff that has solutions that work it out. But when we get to calculus, we get to points to say that, okay, the equation doesn't have to have a solution to have a solution. We'll discuss that in calculus 1. A limit does not have to exist for it to exist. So that's why I had this discussion here, because we're getting to that point is, for example, if I had an equation that looked like this. If I'm looking at an equation and as I come in closer to 4 from the right, what value are these numbers approaching? Yeah, if I come into 4 from the left, what are these values approaching? 3. So when I get to 4, what do you propose is going to happen? Is it going to get to 3 or not? Well, even though there's an open circle here, that won't matter. We're going to say that the function, the limit of the function, approaches 3 when x approaches 4. So the answer doesn't always have to exist to exist. That's the cool part about calculus. And you guys are getting ready for that after this course. Okay. Intercepts. Tell me the slope of these equations the graph of these equations and the intercepts. Okay, first one. What's the slope of this one?
0.
What's the slope of this one? Let's skip the graphs right now. So what's the graph of this one look like? So it's a horizontal line on 3, exactly. So at 3, we got a horizontal line. How do we know it's horizontal line? Except, well, so the other example is the intercepted y. There's no slope, but there's something even more obvious than that. There's no x. You can only have an intercept if you have that letter in your equation. Since there's no x, we can't cross the x-axis. Only way a line cannot cross the x-axis is if it never approaches it. So it's got to be horizontal. It has to be parallel to the x-axis. For example, this one, since all the y values are the same, let's say we have that x 0 over 1. The slope is 0. This one, what does the graph look like? Vertical line through -4. Again, there's no y value, so it can't wiggle any. It's got to go vertically straight up. It has to be parallel to the y-axis. So the slope of this one is reciprocal of this one. So that's 0/1. This one's 1/0. They're perpendicular to each other. We're gonna learn different terms. Orthogonal, perpendicular, orthonormal. All these terms I will be using for the same concept. It's gonna be perpendicular to each other. What are the intercepts? What's the x-intercept? Undefined is not gonna be right because this doesn't exist. It's not 0 because 0 is a number, so it doesn't exist. What's the y-intercept? Where? Where?
0.
0, 3.
0, 3. It's a location we're looking for. You're right, it was 3, but how about the x-intercept here? Very good. Y-intercept? Good. Without looking at your notes. Did everybody get a sheet from the back of the room when it came in? There are 2 sheets. There's the schedule sheet of this course, and then there's also this sheet, the library of functions sheet. So if you don't have one, go get one back there, because that's what we'll be doing now. It's on the back table when you come in. Yes.
Or is it just like?
Well, no, we're doing all this stuff in there in the schedule. Let me see. Functions. We talked about functions. What's another way of writing a function? What is that equal to? F of x is equal to what? Y. F of x equals y. Y equals some function of x, some equation. The graphs of a function. Well, and the properties of functions and all 3 of these go together. And that's the stuff we did last time. Now I gave you the chart. Without using your notes, but using your neighbors, fill these in. I want you to tell me these things. Give me the graph of the function, the domain, and the range.